So today we're using the fundamental theorem of algebra, which says, there's a lot of things that it says, but what we're going to get out of it is that the degree is going to tell us how many solutions there are. Now remember, sometimes the solutions can be repeated, where it might pass through x equals 2 twice. So, but that would count as two different solutions, not two different, but it would count as two solutions. So when I ask you how many solutions there are, and you tell me the degree is 3, so there's 3, or the degree is 4, so there's 4. That doesn't tell you if any of them repeat. That's just telling you how many solutions there are. And then this one was 4, and then this one was 3. Okay, now we're going to find all of the solutions. So the first thing you're going to do on this example is graph on your calculator this equation, example 2. Where is it? So go ahead and graph the equation on the calculator. If you have trouble with your calculator, call me over so I can help you with it. Don't just sit there quietly, but come over so I can help you with it. Yep.
We need to put in 0x to the 4th, or is that not doing it? Okay.
You don't have to for the calculator. You will when we do work.
Oh.
Get a graph. If your window is all out of whack, you can hit what? Zoom 6 fixes the window. You're going to sit up there and plug it in. Okay, so I have the graph up here also. Does yours look like mine?
Yeah.
So what x-intercepts does it look like we have? Okay, I'm always going to read this left to right. Just the same way you read. -1, +2. How many solutions should we be getting?
5.
We should be getting 5 solutions. Or 5 zeros. I should change the word to zeros. 5 zeros. We should be getting 5 zeros. But the way it looks like on our picture is there's only 2. Actually, it looks like there's 3. Who can tell me why?
The negative
One
one.
is where it costs a -1, it hits it, and that counts as repeating if it's.
Okay, remember it is repeated. If it hits it and it goes back the other direction, if it doesn't pass through the axis, then it's repeated. Remember that we did last week? Yeah, it kind of looks like a parabola right there. What is happening? Oh, probably.
What?
Your charger was making noises.
Am I messing your computer up?
Yeah. It's fine. I just couldn't figure out what was happening. Anyway, so if it hits at -1 and it has a parabola, there's actually 2 solutions there. How many solutions are at +2? Just 1 because it passes through. So we have 3 solutions so far. We are missing 2. Let me write down the ones that we know for sure. We should have -1, -1, and +2. But we are missing 2. So probably the other 2 are imaginary solutions. Probably the other 2 are imaginary solutions. So I'm going to show you how to find them. Okay? What? You have a problem? Oh, okay. I know what you're talking about. All right, so what we're going to do is we're going to start with the first 0 that you think it is, -1. And we're going to use synthetic division to factor out that -1 from the original question. So remember synthetic division, I'm going to write down a 1, and then what comes next?
0.
A 0, and then 1, -2, -12, -8. Why did we put the 0 there?
Because the fourth square is gone, so.
Because to the 4th power was not there.
Oh, fourth square.
So go ahead and do your synthetic division. Remember, bring down the 1, then we multiply, get -1, then we add. -1, multiply, we get +1, we add, we get 2. We multiply, get -2, we add. -4, multiply, get 4, we add, get -8. Multiply, get 8, add, get 0. Woo! Now, it should be 0 if it really was a 0. So if that doesn't end up at 0 at the end, you've either done something wrong in your synthetic division, or maybe it didn't really pass through that number. Okay? Now, what we're going to do is, I'm not going to write out the equation, because I'm going to use synthetic division again, so I only want the coefficients. This time we're going to use synthetic division with the second answer. What's the second answer? -1 again. So I'm going to put a -1 out here, and I'm going to redraw that synthetic division box. And I'm going to do it again from the answer that we got from the first one. Not including 0, because that's just a remainder. It doesn't actually matter if you include it or not. It's not going to affect it.
I guess we need to put 0.
After we take that out, we have a 0 remainder left over. We're going to do it again with the 2 that we got the answer with, the 2. So I'm going to bring this down, multiply. So you'll notice I'm just using the previous synthetic division problem to do the new one. Save myself some time. I don't want to have to rewrite everything every time. So that was step 2. I'm going to write what I have left over, but we didn't only do synthetic division once, we did it 3 times. Remember, when we do it once, that lowers the degree by 1. So if we do it 3 times, where the degree started at a degree of 5, and if I do this 3 times, what's the degree now going to be? It's going to be squared, because each time we're going to lower it by a degree. So this will be x squared plus 0x, yes, plus 4. And we're going to set that equal to 0 so that we can solve for everything else. You didn't have to write the 0x. I wrote it just so you saw where my numbers come from. You didn't have to write the 0x. So in fact, I'm not even going to write it down here. Now, in the directions, it says solve for the remaining zeros using quadratic formula, square roots, or complete the square. So it's really up to you what method you want to use, but sometimes square roots works and sometimes it doesn't. Square roots would work for this one, so I'm going to use square roots. Subtract the 4. And then when you take your square root of both sides, what also special thing do you have to do? Plus or minus. Well, that's specifically for this one, but if we square root it all, we would need to do plus or minus. So I'll have x equals plus or minus, and that will be 2i. How many answers did I just get? 2.
Imaginary.
2 imaginaries, plus I had the other 3 from before, so I do have a total of 5, which is what I needed. So let's list all of our solutions. -1, 2, plus minus 2i. And that's where the -1 was repeated, right? That was when it was repeated. And when you've got that copy down, you're ready to go on. Flip the page over. What's the first step?
Graph it.
Graph it on the calculator. That's the first step. So graph it on the calculator. And how many solutions should we get?
3.
Or zeros, I should say zeros. Now, when you graph yours, if you type it in wrong by accident, you can check and just look at mine and make sure that you didn't type it in wrong. Start figuring out where you think the zeros are. Can you look in your table to help? Yeah. But zeros are not the y-intercept. The zeros are not the y-intercept. Only the x-intercepts. Only the x-axis is what we're looking at. So where do we think they are?
33.
-3? Do either of them look repeated?
No.
Let me zoom in. I'm going to go to Window, and I'm going to change my X minimum to be like -4 to 0, and my Y minimum maybe -2 to +2, just so I can like really look at that area of the graph that appears to have the zeros. So it looks like it passes through at -2. But what's happening at -3? Is it passing through it? Or is it making like a parabola at -3? I meant -2. I'm totally saying backwards, aren't I? Whoops. Okay, let's start that again. At -3. Sorry.
-3, -2.
So -3, it passes through. But what happens at -2 right there? It makes a parabola. So what does that tell us about the solutions?
It's repeated.
That it's repeated. But don't worry, we'll figure it out as we're using our synthetic division. How do I make that go away? Oh, there it is. So we think that this one's repeated. So we're going to do our synthetic division. We'll start with -3. Take that out. So I've got 1, 7, 16, 12. -3 worked. So we'll take out -2 next. And that one worked. So then I'll try -2 again, because we thought maybe that was a repeated solution. Okay. Going back a step, the green step, if I didn't even have to really do the last step in red, if I went back to the green step, and I just wrote this equation equals to 0, let's see. It would have been x plus 2 equals 0, so x equals -2. I could have done it that way also. Okay, so I found all the solutions that we needed to find. -3 and -2, whereas -2 is repeated.
On that test, would you need to like identify that -2 is repeated?
Only if I ask you to.
Or? Okay.
In higher level things, if I just say find the zeros, you find the zeros.
Yeah.
If I specify saying, tell me about the multiplicity, or any of them repeated, something fancy like that,
Big
but
word.
you know what multiplicity means, right?
Yeah.
Happens multiple times. So only specified on your homework. You won't write them repeated on your homework. All right, next one. Did you graph it? Are you graphing it? You're doing it right now? Excellent. If you changed your window on that last one with me, how do you fix the window?
Zoom 6.
Good. Zoom 6. Zoom 6. How many solutions should there be for number? There should be 5 solutions. And the degree is 5. There should be 5 solutions. Where does it kind of look like the first solution is if we go left to right like we read? And does -1 have any repeats?
No.
No, because it passes through. What's the next solution?
1, but 1 is repeated, so that's 3 for solution.
Okay, so 1 repeats so that it looks like that 1 happens twice. All right. So we should have 5 zeros. We think -1, 1, and 1 are 2 of them, or 3 of them, I mean. So what would the other 2 be? If you can't see them. Yeah, if you can't see them, then the other would have to be 2 imaginary. If you can't see them, they're not there, they're imaginary. When we do our synthetic division, the -1. So I'm just doing my synthetic division for each 0. And once you've gotten to the last step and you've taken all the real zeros out, we've just solved for the imaginary ones. So we're going to write this as an equation. It's going to be x to the what power to start? It was to the 5. We took out 3 zeros. So it'll be to the second minus 2x plus 4. And then we have choices. We cannot use square roots for this one, because the middle term cannot be square rooted. It is not a square. You cannot use square roots for this one. So we are down to 2 choices. Quadratic formula or complete the square. Well, we can't do factoring because if it could be factored, we would have seen the zeros. We didn't see them, so they've got to be imaginary.
I might reach for the solution, but.
So you can either use complete the square or you can use quadratic formula. One is easier than the other in certain cases. I've already done it both ways. I know that complete the square is easier, so I'm going to do quadratic formula because I know complete the square is easier for this case. So I'm going to show you with quadratic formula, plus another excuse to sing the song. Ready? What is it? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. That's why we do it over and over and over again, so we can learn it. When you get into your next course, you have to know it. When you get into math, you hit a 0 on things. Okay, so x equals positive 2 plus or minus square root of 4 minus 4 times 1 times 4 all over 2 times 1. We simplify that, we get 2 plus or minus square root of negative 12 all over 2. And we knew we were going to get an imaginary answer, didn't we? We knew that. So this confirms we're doing it right. How do I get square root of negative 12 to simplify? I don't remember, I'm sorry. Huh? Right. We have an I, and then square root of 4 and square root of 3. And that square root of 4 becomes a 2. So I will rewrite this as x equals 2 plus or minus 2i radical 3 all over 2.
Can you write it as 1?
Whoa, yes, I'm going to do another step. What were you going to guess?
Just 1 plus or minus.
Yes. So in order to simplify it, that 2, the bottom 2 has to divide both terms on top. It can't just divide one of them. It has to divide both of them. So we'll do 2 over 2 plus or minus 2i radical 3 over 2. And then those 2's will cancel. But they don't disappear. It becomes 1 plus or minus I radical 3. And that is 2 answers. One is plus, the other is minus. We've already found the other 3, so we have all of them. We just list them. X equals negative 1, positive 1, 1 plus or minus I radical 3. And which one was repeated?
1.
Well, when you do your assignment, it won't even give you the option of writing that twice. So you shouldn't be writing it twice. I mean, if you feel the need to say that it's repeated, you can, but you should be writing it that way. Where we know it's the same number, we don't write it twice. Okay. All right, last section is conjugates, which we did on Friday. We did conjugates on Friday, so if you were absent on Friday, this is the same lesson we did on Friday. Only today, it's going to be complex conjugates, which means imaginary number conjugates. So if I have a plus bi, that's an imaginary number. If that is one of the solutions, it can never be just one imaginary solution. Never be. Remember, we were just solved some, and they always came out as plus or minus. So if you know that one answer is negative or imaginary, then you also have a second answer that is its conjugate. So you just switch the sign in the middle. That's all. Switch the sign that's on the imaginary part. So we'll go through all these steps, same steps that we did on Friday. It's just this time we have i's instead of square roots. Same stuff though. So we're going to start, and everything that it is saying in this equation is that these are very basic. There's no repeat numbers. They're going to start with the number 1. The part that you need out of everything it says here is the zeros at 2 and 3 plus I. The zeros at 2 and 3 plus I. That's the part that you need. We start by writing x equals 2, x equals 3 plus I. Is it okay if I just have 3 plus I by itself as the solution? It is not okay, because imaginary numbers always come in pairs. There's always the conjugate, so I have to know to write the third answer. What would it be? You only switch the sign in the middle. Then what do we do? Make each equation equal to 0. So for this one, I'm going to take away 2 from both sides. For the middle one, I'm going to take away 3 and take away I. So I will get x minus 3 minus I equals 0. And then for the last one, I'm going to take away 3 and add I. X minus 3 plus I equals 0. Then what do we do? What do we do next? Make them in factors. Write them as factors in parentheses, right? So we'll have x minus 2. We'll have x minus 3 minus I. And x minus 3 plus I.
Just the 3 and the I, that kind of one term or that.
It'll be separate terms. So terms are separated by plus or minus signs, so it is a 3-term and a 3-term.
I just didn't know if that was meant for it, so that's part of the I.
Nope. Nope. Since it has a plus or a minus sign, it's separate. Okay, so remember which ones we should suggested
ones.
multiply together first.
X minus 3 minus I and x minus 3 plus I.
Suggested we do the 2 second parentheses twice, because it looks more complicated up front, but it will make it easier in the end. Okay, so we're going to stay organized, and we're going to distribute the x first. We're just going to distribute the x first. So we'll have x squared minus 3x plus ix. And I'm changing colors each time so you could hopefully follow my work. The next thing that I'm going to do is distribute the minus 3. Boom, boom, and boom. Minus 3. So we get negative 3x plus 9, and then minus 3i.
Oh, no, I have that.
And then we're going to distribute the minus I to all 3 terms. So that's going to be minus ix plus 3i and minus I squared. And I will stop talking for a moment so you can catch up. It's distributed just like we did on Friday. Same stuff. And then from there, some stuff should cancel, right? We're going to write what we have left over. X squared minus 6x, those cancel. Plus 9, those cancel. So what does I squared equal?
So minus negative 1 is really plus 1 is 10. But are we done yet?
Are we done yet?
No.
Are we there yet? You're not. But what's nice is once you multiply together the two that have the imaginary numbers, all the i's should be gone.
They disappear.
They should be gone, right? So then we're gonna just distribute the other factor from earlier. I'm gonna factor, or I'm gonna multiply the x times everything first. And multiply the minus 2 times everything. And, oh, I forgot my f of x. Oh my gosh. There you go. And then, once we set it up, it's the same as Fridays. So as long as you understood Friday's lesson, you should be pretty easy. We're going to just set up the last 3. We're not going to multiply them all the way out. Just want us to set up, write the factored version of the last 3, so I can check to make sure you're getting all the right factors that you would multiply together. Okay, so on those last 3, get to the part where they're just in parentheses before you multiply it out. And I'll put the answers up so you can check. Okay, so we're not rushing through this. We just spent some time talking about what happens when you have an imaginary number as one of your factors. What happens if one of these is imaginary? X equals 4i. What happens if one of them is imaginary? If one of them is imaginary, there has to be 2 of them. So what's my other one going to be? Negative 4i. I went up and down because of space, sorry, that's confusing. So I have negative 1, I've got 4i, and I've got negative 4i. So when I write those as factors, the first one would be x plus 1. The second one would be x minus 4i. And the third one would be x plus 4i. The commas separate the factors. The commas separate factors. So try number 6. We're not going to multiply out 5 or 6. We're not going to multiply out. Just get to the part where I stop. Number 6? Oh, you were going. Well, I have answered. So this is 1 plus. I wrote that, like that's 1 times. The commas are separated. All right, I see a lot of people making up terms that aren't terms on this one. Seen it at least 3 times now. X equals 3 is the first term, or is the first 0. The second 0 is everything after the comma, because there's not another comma. The commas are separating the zeros. So it's only giving you 2 zeros. The second one is x equals 1 plus I radical 5. That's the second one. So is that all we have? 2? You have to have a second imaginary number. So it'll be 1 minus I radical 5. And then we write them all in factors. So the first one would be x minus 3. The second one would be x minus 1 minus I radical 5. The third one would be x minus 1 plus I radical 5. And then you'd multiply them all up, but we're not going to take the time to do that right now. Do the third one. Set up the third one. Look at how many commas are there. That's gonna at least tell you, how many zeros there are to start. Grab your computer if I said good. Oh, you're okay, hold on a second. That one, find that out. The last two. You can go back and multiply out. Okay, what do we do to radical? We have a square root. Can there only be one square root? Can there only be one square root by itself? Oh. Okay, so looking at this last one, you see x equals radical 2. You see x equals radical 2? Can you only have one square root answer by itself? No. There also has to be x equals negative radical 2. All square roots, there has to be a plus or a minus. And then we also have x equals 1 minus 3i. Can there be one imaginary answer?
No.
So there also has to be x equals 1 plus 3i. So how many factors, parentheses, will I have?
Quattro.
So I will have x minus radical 2, x plus radical 2, x minus 1 plus 3i, and x minus 1 minus 3i. And that's what I would multiply all out. If you feel like this is pretty easy for you, and you really get this factoring and multiplying out, the book actually explains how to multiply it out in a much easier way. But you have to understand what you're doing to understand the way the book is explaining it. But if you'd like to save yourself some time and paper, you're more than welcome to look at the book way or ask me about it. I can explain it, but I wasn't going to do it to everybody because not everybody, I don't want to confuse anyone. Okay, but there is a more advanced way of doing it, but it's easier, but it's more advanced. So if you feel like you're getting this and you're good at Algebra 2, feel free to ask me about it. It's how to multiply those out. Just make it easier on yourself. The assignment is Big Ideas on line 4-6, and we have 10 minutes. So grab a computer.
5